Okay, today we are going to be determining whether a expression is a polynomial or a non-polynomial. Thinking about this, polynomials must always have positive integer exponents and the operations of addition, subtraction, and multiplication. What this means is you have to be able to write the expression without division while keeping all exponents positive. I think with determining whether an expression is a polynomial or not is better when you go through examples. So let's look at some examples. Before we get started, let's just note this really quick. Remember, in order for it to be a polynomial, it has to have positive exponents at all times and be able to be written as a non-fraction or without division. Remember, non-polynomials have negative exponents. So negative exponents, and it cannot be written without division. So negative exponents. As a little note, this is the quickest way. Positive exponents. All right, so let's look at some examples. Let's look at some examples. Example number 1. Let's say we have 2x plus 3. We want to determine whether or not this expression is a polynomial. First thing I'm going to do is I'm going to look at my variable to check its exponent. What is the exponent of this variable? It is a 1. Do I have any negative exponents here? No. Do I have any division here? No. So this is definitely a polynomial. Example number 2. Let's say I have 6 divided by x to the power of 4. Do I have any negative exponents? Currently, I do not. But remember, I cannot write it with division. So if I wanted to change this, I would have to take the reciprocal of x to the power of 4. And this would give me 6 times x to the power of negative 4, right? Because I'm taking the reciprocal, which is 6x to the power of negative 4. We cannot have negative exponents, which means this is a non-polynomial. Number 3, example 3, I have negative 84 x to the power of 9. Again, check my exponent. My exponent is positive. Do I have any division? No, I do have a negative coefficient, but that is not a part of determining whether it's a polynomial or not. So this expression is very much a polynomial. Number 4, I have the square root of 4x. The square root of 4x. This is the same as saying the square root of 4 times the square root of x. The square root of 4 is 2. But when you have the square root of x, this is going to be x to the power of 1/2. We know that there's already a 1 here. And then when you don't see a number, this is a 2, which means this ultimately becomes 2x to the power of 1/2. As you can see here, we have a fraction exponent. We have a fraction exponent. Non-polynomials have fraction exponents, right? Non-polynomials have fraction exponents. Polynomials have positive integer. Very important. Positive integer exponent. So in this case, we have a fractional exponent, which means this is clearly a non-polynomial. Example number 5. Let's say we have, this is a good one. Let's say we have 6x squared plus 3x divided by, right? Let's get a little complicated. Divided by 3x. Divided by 3x. We're going to simplify this, right? So I have 6x squared plus 3x, and it's all divided by 3x. So divided by 3x, divided by 3x. 6 divided by 3 is 2. x squared divided by x1. Remember, keep the base, subtract the exponent, so that gives you just x, plus 3x divided by 3x is 1. So now I look at this. Is my exponents positive integers? Yes, 1 is a positive integer. Do I have any division that I need to look at? No. So we know for a fact that this is a polynomial. Here is 5 examples that we use to determine whether the expressions was polynomial or non-polynomials. As a recap, polynomials have positive integer exponents. Positive integer exponents, and must be able to be written without division while keeping positive integer exponents. So if you have division and you change it so that it's non-division or doesn't have any division, your exponents should remain positive in order for it to be a polynomial. Non-polynomials, negative exponents, fraction exponents can only be written as using division, right? Any questions on this, please follow up with me. Please log into Hakima, visit hakima.org, or comment on the video below. Any questions on whether an expression is a polynomial or non-polynomial, please follow up with me.